First, you write the definition for this related rates of change. First topic is that related rates of change. Related rates of change. A related rate of problem. No need to write, just listen. At the end of the class, I upload that video of this class in the YouTube. I can give the link afterwards. So no need to write, just listen. In case any important point is there, please make note down. That's all. A related rates problem is a problem which involves at least two changing quantities. That is, in case two dimensional, it is a x axis and y axis. It is x axis and y axis. What is dy by dx? Dy by dx means rate of change of y with respect to x. That means rate of change of y with respect to x. So here also two changing quantities is there. X also changing based on that x, y is changing. At least two changing quantities and asks you figure out the rates at which one is changing given sufficient information on the all the others. That means they are giving that rate of change for the one variable, then you can find that the change in the other variable based on first one. See, for instance, when two vehicles drive in different directions, we should be able to deduce the speed at which they are separating if we know their individual speed and directions. So in case x and y are two variables, and then it is like x vehicle, it is like y vehicle. If the information of speed of x vehicle and y vehicle, then if rate of change is available for x only, we can find that rate of change of y. Okay. See, we will discuss few problems in this related rates. First example, if we blow air into the balloon of spherical shape at rate of 1000 centimeter cube per second, so it is the rate of change. At what rate the radius of balloon changes when the radius is 7 centimeter? That is one parameter available here, and then rate of change is given. Then we have to find the rate of change of the other one. So also compute the rate at which the surface area changes. First we know that what are the formulas for volume and the surface area of the balloon. Balloon means it is like spherical shape. That is the extension concept of the circle. If it is a circle, then area is pi r square, and then circumference is 2 pi r for the circle. But here we are discussing about that the 3D concept of circle. What is the 3D concept of circle? Sphere. Okay, you can consider one bangle. If you rotate the bangle continuously, then you can see the sphere when bangles continuously rotate. Okay, so here that is a very simple example for the sphere, real time example. The volume of the radius r balloon of radius r is v equal to 4 by 3 pi r cube. It is the volume of sphere formula. We are given here dv by dt. So we are given that the spherical shape at the rate of change. That means V equal to 4 by 3 pi r cube volume. Then volume is changing at 1000 centimeter cube. That means dV by dt. So here what is T? T is per second. T is per second is given. And we need to find dr by dt. We need to find rate of change of, see that at what is the rate of change of radius? What is known as rate of change of radius? If r is the radius, then dr by dt is the rate of change of radius. So if we differentiate on both sides, we will get that d by dt equal to 3 into 4 by 3 pi, keep it that r cube differentiation is r square dr by dt, but substituting r equal to 7 here. So because here given r equal to 7 na, at 7 centimeter, what is the rate of change? So r equal to 7 is given, substitute in this formula, then we know that what is pi value, 24 by 22 by 7. That is substituting r equal to 7 and dv by dt equal to 1000. Substituting that value, we will get that 1000. Right hand side, sorry, left hand side is 1000. That is equal to 4 pi into 49 dr by dt. So we will get that dr by dt equal to 1000 pi 4 into 49 pi. That means 250 by 49 pi. It is one result for the rate of change of radius. That is the first question. It is the first question. Then what is the second question? Second question is also compute that rate at which the surface area change. What is the surface area? Now we'll see the next slide. The surface area S of the balloon is 4 pi r square, because 2 pi r is the circumference of circle. Then multiple with 2 pi r, sorry, multiply with 2r, then we'll get that 4 pi r square. Easily you can remember that 4 pi r square is the surface area of that sphere. So if you differentiate on both sides with respect to t, we will get the ds by dt equal to 8 pi dr by dt. So substituting r equal to 7 here, and then dr by dt is what? 250 by 49 pi. So in the last slide we have found na, dr by dt is 250 by 49 pi. Substitute this, you keep it that this is equation number 1, result number 1. Then substituting result 1 here. So here substituting result 1, we will get that ds by dt equal to 8 pi into 7 into 250 by 49 pi. That is equal to, here pi get cancel, and then 7 49 get cancel, here 7 is there, 8 into 250, 2000 by 7. Okay, if you want to write that in terms of number, no need to write that the pi here. So you have to substitute that pi equal to, sorry, what happened? Any doubt is there? Any doubt?
No, sir.
Then why are you switch on your mic? So here the rate of change of radius is 250 by 49 pi, and then rate of change of surface area is 2000 by 7 centimeter square by second. Next example is the price of the product is related to the number of units available by the equation px plus 3p minus ca 16x.
Sir,
Yes.
sir, sir, I didn't complete the before sum.
நான் தான் சொன்னேனேப்பா கம்ப்ளீட் பண்ண வேணான்னு.
Okay, sir. Okay,
இல்லை இல்லைப்பா, நீ இடதும் விட்டுருங்க. இன்கேஸ் ஃபுல்லாக எழுதுன்னு அவசியம் இல்லை. நான் தான் இந்த எண்ட் ஆஃப் த ஹவரில் நான் அப்லோட் பண்ணுறேன்னு சொல்லியிருக்கிறேனே.
okay, sir.
டைம் வேஸ்ட் பண்ண வேணாம். ஏன்னா டபுள் த நீங்கள் எழுதுனீங்கன்னா டபுள் த டைம் போயிடுது.
Okay,
அதனால நான் யூடியூப்ல போட்டுடுறேன், நீங்கள் பார்த்து அப்புறம் எழுதிங்க பொறுமையாக. ஒன்றும் இது இல்லை, பிரச்சனை இல்லை. சரியா?
okay,
ஈவன் இன்கேஸ் பின்னால் உங்களுக்கு எதாவது டவுட்னா கூட இன்னும் 2 to 3 டைம்ஸ் நீங்கள் அதை அப்படியே பார்த்துக்கலாம். அதுக்காக ரெக்கார்ட் பண்ணுறேன்.
okay, sir.
சரிங்களா?
Okay,
ஓகேப்பா.
thank you.
See that? See the example. The price of the product is related to the number of units available. That means supply. By the equation px plus 3p minus 16x equal to 234. இது ஒரு equation where p is the price of the product. What they are giving, p is the price of the product per unit in rupees, and x is the number of units. X is the number of units. So what is called the supply? Supply, if you multiply that price of the product and the number of units, then we will get the what is the supply rate. Find the rate at which the price changing with respect to time when 90 units are available and the supply is increasing at the rate of 15 units per week. So the supply increasing at a rate of 15 units per week. What is supply here? We have to find P. P is the supply. Sorry, P is the price of the product per unit in rupees. So here we have to find that rate at which that price is changing. Rate at which the price is changing. So what is the rate here? Price of the product P. We need to find rate of change of price. That means dp by dt we have to find. So P equal to 234 plus 16x by x plus 3. Then what is dp by dt? dp by dt is that x plus 3. So 234 by x plus 3 is p is a function of t. It is like chain rule. Sorry, p is a function of x. X is the function of t. X is the function of t. Because what is x here? Number of units. So 90 units are available here. X equal to 90 is available. X equal to 90 is available here. Then when you are differentiating that, that is called the chain rule. What is dp by dt here? dp by dt is dp by dx, dp by dx into dx by dt. So first we have to find the dp by dx here, then dx by dt. Afterwards you can write that. Then substituting x equal to 90, dx by dt equal to 15. Because here see that the supplying is increasing at the rate of 15 units per week. So number of units is increasing, 15 units per week is increasing. Therefore dx by dt equal to 15. Substituting x equal to 90 plus 3, 93 square into dx by dt is 15. So we will get that minus 0.32. That is the price is changing. In fact, the decreasing at rate of 0.32 per unit. Next problem is salt is poured from a conveyor belt at the rate of 30 cubic meter per minute. Cubic meter, it is not centimeter. Cubic meter means m cube. Otherwise, no need to write c here. Cubic meter means m cube, 30 m cube per minute, forming a conical pile with a circular base whose height and diameter of base are always equal. How fast is height of the pile increasing when the pile is 10-meter height? So here we can write the solution. You know that h and r be the height and base radius. See here, this is the height h, and then base is the radius r. So h equal to 2r. H equal to 2r here. Let V be the volume of the salt. V be the volume of the salt. It is conic na. So V equal to 1 by 3 pi r square h. That is a formula for cone. Volume of the cone. V equal to 1 by 3 pi r square h. But you have to substitute r equal to h equal to 2r, r equal to h by 2. Then you will get that 1 by 12 pi. Instead of r we are substituting h by 2 na. So 1 by 12 pi h cube. Because here given that why you are taking that h equal to 2 here, that means height and the diameter of the base are always equal. See, radius is r, diameter is 2r. Diameter is 2r. So height and diameter are equal, mean h equal to height equal to 2r. Okay, so based on this we are substituting here dv by dt equal to, that is given 30 meter cube per minute. So here given salt is poured from conveyor belt at the rate of 30 cubic meter per minute, forming a conical pile with a circular base whose height and diameter of the base are always equal. Then here given that the rate of change of volume, that means dv by dt equal to 30 meter cube per minute. So dv by dt equal to 1 by 4 pi h square dh by dt. So what is dh by dt here? So what is the question here? How fast is height of the pile increasing? It is the question. So if h is the height, how fast that height of the pile increasing? That means they are asking about the dh by dt. So what is dh by dt? Substituting dv by dt value and then cross multiply everything, we will get the value. So 4 into dv by dt is 30 divided by h is 10 meter height. Listen here, everything given in meter. In case everything given in one thing is given in meter, the other thing is given in centimeter, we have to change into either to centimeter or meter for using the same unit for the problem. So here for all the parameter you have to use the same unit. You should not use the different unit for the different values. In case the given problem is given in centimeter, in case 10 meter is given, then you have to change into the centimeter. Okay, so here dh by dt has find here 6 by 5 pi meter per minute is the answer for this. Next one is two variable related rate problem. What is the two variable related rate problem? It is one important problem here. A road running north to south, crossing a road going to east to west at the point P. So here given a road running north to south. So this north to south road and then east to west at the point P, joining point, east to west point, joining at P. A car A is driving north along first road here. First road and car B is driving east along the second road. East along the second road is the second one. So here what is the point? X value is 0. If you taking this as x-axis, this as y-axis, then this point is 0 comma a of t. This point is here y value is 0 and then b of t is the point here. It is car A. So this is car A is the running here, car B is driving here. At a particular time, car A 10 kilometer to the north of P here. Car A 10 kilometer to the north of P and traveling at 80 kilometer per hour. 80 kilometer per hour. That means if you are taking that speed 80 kilometer hour, while car B is 15 kilometer to the east. So this distance is 15 kilometers to the east and then traveling 100 kilometer per hour. It is traveling 80 kilometer per hour. Car A is 80 kilometer per hour. Car B is 100 kilometer per hour. How fast is the distance between two cars changing? How fast the distance between the two cars changing? Actually, last week I will send that one video link to you. I don't know how many of them are seeing that. That is a basic for the calculus, a basic for calculus or history of calculus. I have seen that. Sorry, I have sent that. Have you seen? Am I sent or not that one? I'm asking.
Yes, sir. Yes, sir.
That is what is the topic of this video?
Which one, sir?
No. Last week I have sent one video. I don't know exactly whether I sent that or not. Basic. Just wait. I,
Basic differentiation rules and problems, sir.
no. Not like that actually. So I will show that. Just you note down that because if that calculus is new to you, for the better understanding, You can go to YouTube. In that YouTube, um, so here physics 3 blue 1 brown. Am I shown that? This one 3 blue 1 brown. No, am I shown that or not? 3 blue 1 brown channel.
No, sir.
No, sir.
No, na. So here in that videos, come down. So you can note down that 3 blue 1 brown. It is very useful to you. The essence of calculus. Totally 9 or 12 for episode 9. See that it is start from the essence of calculus. In the essence of calculus episode 1, season 2 episode 1, and then up to 10, 11. Yeah, 11 videos are there. What is everything they have given in terms of, see here that limits and continuity also they have explained very simple way. So in the essence of calculus, what oh, oh my god, just wait. See how they are changing that, what is called the rate of change, everything they have given in that. Okay, did you note down that the channel name?
Yes, sir.
Okay, okay. 3 blue 1 brown. One more is physics videos of Kavransky. It is Russian name actually. Physics video by, not physics video on, physics video by Kavransky. So in that YouTube video also, they've explained the basic things, not only that calculus, the whatever required for your basics, particularly for your optometry class. Uh, if you are seeing through pictorial explanation for this basic concepts, it is very very useful one. Even this 3 blue 1 brown, this channel also very very good one for explaining in that very simple way. Okay, fine. Now we will see that, see the solution for this
Excuse me, sir.
is
Repeat the name of the second channel.
physics videos by
The one of
basic
physics
video
videos
first.
by.
Physics videos by, just what I will show that. Not able to take. Are able to
Okay,
this.
thank you.
Just wait. Just wait. Just wait. I'll show you. YouTube. Go to YouTube. Okay, fine. Even few more good channels are there. This one. This one. Physics videos by Agent Kutroyansky. It is fully pictured video. This yeah, all the videos have explained through picture only. Graph that mean graphics, through graphics. Did you note down that? Can I close the screen?
Yes, sir.
Okay. Now we'll see that let A of t be the distance of the car A north of P at time t. A of t be the distance of a car A north of P at time t, and B of t. So they are taking that distance from that point origin. If you're taking this as 0 comma 0, if you are taking that 0 comma 0, that is the origin. If you are taking this as x-axis, if it is y-axis, and then the distance as given, and then the point is b of t comma 0, this point is 0 comma a of t. Let c of t be the distance from a car A to car B. This one, this distance is that c of t. But by the Pythagoras theorem, c square equal to a square plus b square. So c square equal to a of t whole square plus b of t whole square. Taking derivative on both sides, 2c of t c dash of t, that is equal to 2 a of t a dash of t plus 2b of t b dash of t. Therefore c dash equal to, cancel that a everywhere, 2 sorry, not cancel, 2 everywhere, cancel the 2 on both sides, then c dash equal to a dash plus bb dash by c. What is c here? Square root of a square plus b square. But what is a here? Distance. A dash is rate of change of displacement. See here, what is a here? 10 kilometer. Rate of change is 80. So 10 into 80 plus 15 kilometer is distance. The rate of change is 100 kilometer. Therefore, if you substituting 15 into 100 divided by square root of a square, a is 10, b is 15, so a square plus b square. If you calculate this, then we will get that answer 127.6 kilometer per hour at the time of intersect. So how fast is distance between the two cars changing? So that is that one more example, and then application here is that you have to use that Pythagoras theorem to calculate that. This type of problem is known as the two variable related rate problem. Next one topic is the equations of tangent and normal. The equations of tangent and normal. Usually what is called tangent, if you are taking any one of the curve here, in case any one of the curve here, if you're taking one point on the curve, in case P is the point on the curve, if you draw the line passing through this point, that is called tangent. The perpendicular line to the tangent is called normal, that is called tangent. This is called normal. So similarly, you can see here, if it is a function of x, y equal to function of x, y equal to function of x, then this function, every point the tangent is there. Actually, if you are taking one point here, then you can draw parallel to that this vector. You know the vector, the last unit we have discussed about the vector. So this is called the tangent, and then if you draw the perpendicular to the tangent is called the normal. Similarly here also we can draw the tangent. This is the tangent to the plane, and it is the tangent to the point, and it is the normal to the point. Then what is the application of the tangent and normal in the differential calculus? So how to calculate that? See the definition for the tangent. A tangent line, or simply tangent to a plane curve at the given point, is a straight line that just touches the curve at the point here. Even we can draw the, in case if it is a 3D, If it is 3D, then we can draw the infinite number of tangent for the point. So, in case if it is a three-dimensional analytical geometry, we can draw the infinite number of tangent point to the tangent line to the particular point. So, what is a normal here? The normal at the point on the curve is straight line which is perpendicular to the tangent at the point. The tangent and the normal of the curve at a point are illustrated in the adjoining figure. So in the figure, they are explaining about that what is called the tangent, what is called a normal, and how to find the tangent and normal to the particular problem. See here, consider the given curve y equal to f of x. The equation of the tangent to the curve at the point a comma b. If you are taking one point a comma b here, that is the point. Case if it is the point a comma b, then is given by y minus b equal to x minus a into dy by dx at the point of a comma b, or y minus b, that is equal to f dash of a into x minus a. So this is the one more definition to find the tangent of the curve at the point a comma b. In order to get the equation of the normal to the same curve at the same point, we observe that normal is perpendicular to the tangent. Therefore, the slope of the normal at a comma b is negative, reciprocal to the slope. So this is the normal to the curve, minus 1 by dy by dx, minus 1 by dy by dx at a comma b. Therefore, what is the equation of normal? Whereas dy by dx is there, we have to write that minus 1 by dy by dx at the point of a comma b. Otherwise we can we can write the formula like this. For the tangent, the dy by dx is multiple the right hand side, y minus b equal to x minus a into dy by dx a comma b. This way you can easily remember. For the normal, same dy by dx at a comma b, it is in that multiple in the left hand side, and then the sign is minus here. That is a easy way to remember the formula. Okay. Right now it is 2:45. Take 5 minutes break. Then we'll continue the class at 2:50. 2:50 or 2:55 we'll start. Okay, how to find that the tangent and normal? Tangent formula is y minus b f dash of a x minus a, and normal is y minus b dy by dx at the point of a comma b minus of x minus a. Actually, it is not only that f dash of a, it should be that f dash of a comma b. F dash of a comma b. Okay. Now we'll discuss the problem based on this. See here, two remarks are given. The remark is, if the tangent to a curve is horizontal at a point, the tangent to the curve, in case one curve is there, horizontal to the point mean this is the horizontal point and it is the vertical point. Horizontal at the point, then the derivative at the point is 0, because the rate of change of there is no rate of change. It is in the same direction. Hence, at the point x1, y1, the equation of the tangent is y equal to y1, and the equation of the normal is x equal to x1. So you have to remember this point. At the point of x1 comma y1 to the equation of the tangent is y equal to y1 and the equation of the normal is x equal to x1. If the tangent to the curve is vertical at the point, the tangent to the curve is vertical at the point, then the derivative exists until infinity at the point. The derivatives exist until infinity at the point. Hence, at the point x1 comma y1, the equation of tangent is x equal to x1. The equation of normal is y equal to y1. So it is quite opposite of the first point. Quite opposite to that first point is the second point. It's telling about the horizontal at the point, and the second one is vertical at the point. See the example. Find the equation of the tangent and normal to the curve y equal to x square plus 3x minus 2 at the point. Now, first we have to identify what is the equation of this. It is in the format of x square equal to 4a y format. X square equal to 4a y, it is the parabolic curve. Y square equal to 4ax or x square equal to 4a y, it is the parabolic curve. That means the quadratic equation. Here y equal to x square plus 3x minus 2 at the point 1 comma 2. So here how to find the center of this? How to find the center of this? First you have to see here. We are finding here what is dy by dx. Dy by dx is 2x plus 3. Hence at 1 comma 2. At 1 comma 2 dy by dx is 5. Therefore, the required equation of the tangent is simple, y minus b equal to f dash of a comma b at x minus into x minus a. So here a is 1, b is 2, b is 2. See the equation of the tangent, x minus y minus b equal to x minus a into dy by dx at a comma b. First we have to find the dy by dx for the given equation. Then you have to substitute that point 1 comma 2 in the dy by dx at 1 comma 2. Then you substitute the value y minus 2 equal to 5 into x minus 1. That means 5x minus 5 minus 3 is the equation of the tangent. To find the normal, y minus b dy by dx and then minus of x minus 1. Minus of x minus 1. So y minus 2 equal to minus 1 by 5. Either you can multiple that 5 here. Instead of multiple here, so if m is the tangent of one plane or point, minus 1 by m is the normal. Minus 1 by n is the normal to the. So here we are taking that m equal to 5. That means slope is 5. Then the normal is minus 1 by m. That means minus 1 by 5 we are multiplying here. Otherwise we can multiply that 5 here and then multiply with minus here. So that is the same thing one. X plus 5y minus 11 is the equation of the normal. So what is the equation of tangent here? Y minus b. If I write the dy by dx at a comma b is m, some m value, x minus a. That is the equation of tangent. Equation of normal is y minus b equal to minus 1 by m into x minus a. So these two formulas we have to remember. Next one is, for what value of x the tangent curve y equal to x cube minus 3x square plus x minus 2 is parallel to the line y equal to x. So what is the slope here? The slope of the line y equal to x is 1. the tangent, because y equal to mx plus c, it is a equation of straight line, y equal to mx plus c. See here, slope is m equal to 1. The slope of the line y equal to x is 1. The tangent to the given curve will be parallel to the line if the slope of the tangent to the curve at the point is also 1. Therefore, so what is dy by dx here? 3x square minus 6x plus 1, that is equal to 1. So if we solve with this equation, we will get that 3x square minus 6x equal to 0. So either x equal to 0 or x equal to 2. So this is the question: for what value of x the tangent curve is parallel to y equal to x. And then one more thing, how the slope is y equal to x is 1. That is one point, and one more point is there. How to calculate the slope for the straight line? Anybody? One simple answer is there. Actually, what is y equal to x here? This one is y equal to x. This is a straight line. It's a straight line. That means 45-degree straight line to the curve. Sorry, from the origin is, then it is the 45-degree. Okay, if we calculate the tan inverse of 45-degree, find the tan inverse of 45-degree. That is equal to 1. It is one more procedure to find the slope of the curve. Therefore, what are the points here? 0, minus 2 and 2, minus 4 is the tangent is parallel to the line y equal to x. So here, how to get that 0, minus 2? When you substituting that x equal to 0, you will get that y equal to minus 2. If you are substituting that x equal to 2, then you will get that y equal to minus 4. Next problem is angle between two curves. Angle between two curves. See the definition. Angle between two curves, if they intersect, is defined as the acute angle between the tangent lines to those two curves at the point of intersection. Angle between two curves, if they intersect, is defined at the acute angle. What is meant by acute angle? What is meant by acute angle? In the beginning class, I told the base of trigonometry.
Angle between 0 degree and 90 degree.
Exactly, that is first quadrant. The first quadrant angle 0 to 90 degree is called the acute angle. In case more than 90 degree, then 90 to 180 degree, that is called
Obtuse.
obtuse. Okay, I have given how many angles to you? 4 angles. Acute angle, obtuse angle. Third quadrant angle is reverse or
Reflex angle.
reflection. Fourth quadrant is complete angle or round angle. It is 362, sorry, 272.
Complete angle, sir.
That is 360 degrees complete angle. Okay, fine. Now, angle between two curves. In case if you consider any two curve here in the first, so in case if it is an straight line, if I consider one more straight line here, if I consider one more straight line, in the acute angle. Then what is the angle between two lines? This is the procedure to find the angle of two lines. Two curve may be given. It may be that parabolic curve or straight line curve, whatever it may be. Then you have to find the intersection point of two curves, other two lines. For the given curve, the point of intersection using the slope, what is called the point of intersection here? Point of intersection means, okay, once again I draw the graph here. I draw one parabola here, and then I draw the one straight line here. This point is called the point of intersection. That is intersection of both parabola and straight line. So what is the parabola here? Y square equal to 4x something, and then what is 45 degree straight line? Y equal to x. If you are that is, if you are finding the point of intersection here, if you are substituting y equal to x in this y square equal to 4x, you will get that point of intersection. Okay, that point of intersection may be written as x comma y. That is distance from x axis is what? The distance from y axis. So this is called the point of intersection of two curves. So for the given curves at the point of intersection, using the slopes of tangents, just now we have discussed that how to find the slope of tangents. We can measure the acute angle between the two curves, then y equal to m1x plus c1 and y equal to m2x plus c2. So here m1 and m2 is what? Slope of the curves. m1 and m2 are the slope of the curves. If m1 equal to m2, then the two lines are parallel. See that here. If the two curves are parallel, then m1 equal to m2. And then if m1 into m2 equal to minus 1, then the two lines are perpendicular. The two curves are perpendicular, then m1 into m2 equal to minus 1. So the data theta between that two curves in the acute angle is known as tan theta equal to m1 minus m2 divided by 1 plus m1 m2. Here one more thing is given where m1 and m2 are finite. It should not be infinite. Okay. The next point is, you can see some problem discussed. Find the acute angle between y equal to x square and y equal to x minus 3 whole square. Both of them are in the format of x square equal to 4ay format. X square equal to 4ay format. So here the center is 0 comma 0. Center is 0 comma 0. Y square equal to x square. That is y square equal to x square. First curve. Sorry, not y equal to x square. In case y square equal to x means it is in the format of it is in the direction, the different direction. Okay, so y equal to x square is this curve, and then y equal to x minus 3. The center is changing. 0 comma 3 is the center. 0 comma 3 is the center of the parabola. See, they are shifting the center from here to here, 0 comma 3. Then the equation can be written as y equal to x minus 3 whole square. Okay, so those who are new to that parabolic curves, parabola, hyperbola and ellipse, please you go through that once again. Not once again, you have to study about that parabola, ellipse and hyperbola. Already those who are familiar with that parabola, parabolic curves, please you go through once again. So what is the solution here? Let us now find the point of intersection. How to find the point of intersection? So here y equal to x square is given. That means if you are squaring on both sides, then we will get that. So here also y, it is also y. Therefore, you can substitute that y equal to x square here. So if you are substituting x square equal to x minus 3 whole square, you will get that x equal to 3 by 2. Substituting that x equal to 3 by 2 here, then y equal to 9 by 4. Because y equal to x square na, once you find that x square value, then once you get that x value, then we can substitute the value of x here, we will get the y value also. So y equal to 3 by 2, x equal to 3 by 2, y equal to 9 by 4. Let theta be the acute angle between the two curves. See that if there are two curves then how to find the angle between two curves? So this is the tangent to the curve 1, this is the tangent to the curve 2. Then we can find the angle between two tangents, that is called the angle between two lines. For the curve y equal to x square, dy by dx is 2, and then m1 is dy by dx at 3 comma 2, 9 by 4, 9 by 4, that is equal to 3. So that means 2 into x means 2 into, substituting x value here 3 by 2, 2 get cancelled, then you will get 3. For the curve y equal to x minus 3 whole square, then what is the tangent? That means you have to find dy by dx. You have to differentiate on both sides. You will get the dy by dx equal to 2 into x minus 3. 2 into x minus 3. Once again you substitute the value 3 by 2, 9 by 4, you will get minus 3. Therefore, tan theta, the angle between two curves is theta 1. What is tan theta formula here? See that m1 minus m2 divided by 1 plus m1 m2. Substituting the value here, that is equal to 3 by 4. So theta equal to tan inverse of 3 by 4 is the answer for the first problem. For the second problem, find the acute angle between that y equal to x square, x equal to y square at their point of intersection 0, 1, 0, 1, 1. How they are getting that 0, 1, 0, 0, 1, 1. So this is y square equal to x. Then what is y equal to x square? Y equal to x square is this one. So if you are substituting the value in this equation, we will get that this value is 0, 0. This point is 1, 1. So what is m1 here? M1 is dy by dx, that is 2x. If you are substituting x equal to 1, we will get that first m1, and the slope m2 for the curve x equal to y square. Then dy by dx is 1 by 2y. Then if you are substituting that value, then tan theta 1 equal to because here denominator is there 1 by 2y. In case if it is an y equal to 0, then it will be that infinity na, but that should be the finite. That should be the finite. Therefore, we have to go for the limiting process. Then we have to substitute the tan theta 1 equal to 2x minus 1 by 2y, 1 plus 2x into 1 by 2y. Substituting the value of 0, 0, we will get that infinity, which gives the tan inverse of infinity, that is equal to pi by 2. So at 1, 1, there is no problem at all. We can find that m1 equal to 2, m2 equal to 1 by 2. So once if it is the value, because one, you know that value of 1 by 0. 1 by 0 is infinity. If you are substituting y equal to 0 here, at the point of 0, 0 only, we are not able to get that finite slope. At the time we go for the limiting process here. So that is the tan theta, and then theta equal to tan inverse of infinity. We know that theta equal to tan inverse of infinity is pi by 2. That means 90 degree. At 1 comma 1, very simple. At that 0 comma 0 mean here. The angle between two curves, of course it is 90 degree. Okay. The graphically itself, it shows that at that 1 comma 1, it is 3 by 4. If you are calculating that, that answer is 3 by 4. So the angle between two curves at that point of 1 comma 1 is tan inverse of 3 by 4. That is 325. Okay. So next class we will discuss about that maxima minima. So one or two problems are there. We'll discuss in the next class. Listen, there is no class on tomorrow. There is no class on tomorrow.